got the floor.
Thanks. Thanks, Alan. So good afternoon, everybody. As was mentioned, my name is Dion Nagy. I'm here today to present the common spring canola diseases. This is my creative component presentation as part of my submission to the graduate faculty for requirements for my degree of the Master of Science in Agronomy. And like Alan said, if you've got any questions throughout this, please feel free. I'm used to being in more of a meeting type boardroom session where I have questions, hitting me all the time. So this is a little different, but. So today I'll do a little bit about introduction around my background, why I chose this subject. I'll tell you a little bit about canola. What is it? Canola is a product that, if you're in Iowa, Missouri area, if that's where you come from, I'm sure you haven't seen a lot of it. But it's definitely something that is near and dear to my heart. If you travel within that Western Canada area, especially now, you'll definitely see those yellow flowers out there. I'll be describing a little bit of the history, where canola originated from, some of the health benefits of canola oil, why we grow canola oil, and basically a little bit about seed production, how it's produced from a production standpoint, seed multiplication, and then get into a little bit about how it's produced on the commodity basis. And after that, I'll go through a detailed example of part of the module on one of the diseases that I chose within the module, and then cap it off with a little bit of a summary. So I grew up in a family farm around Esterhazy, Saskatchewan. So if your geography isn't that good, that's basically north of North Dakota, right in that area, about 200 miles from north of the U.S.-Canada border. It's a mixed farm, or was a mixed farm. A lot of cattle. We did have some pigs and chicken, but mostly cattle, and then grain farming. Now, like a lot of farms in the Midwest, there's nobody home on the farm right now. It's just my brothers and I. We have a little bit of investment in that farm, and we either rent the farm out or we kind of go home and farm about 1,000 acres or so just to keep ourselves busy. I graduated from the University of Saskatchewan as a chemical engineer, and I also have my MBA from University of Iowa. If you're wondering how I got that connection, the last place I was at was Muscatine, Iowa. I was there for about 9 years, so I'm familiar with that area, and I was at the Roundup plant there in Muscatine. I have a lovely wife and 2 children. My kids are out of the house now. They're both in university. So one's in New Jersey and one's in Houston. So I tell people I either did a great job or a really bad job. They're about as far away from us as we can possibly get. So I like to think we did a good job. So for fun, we like to hike, golf, coach volleyball, and travel. Just like a lot of people. So my personal work history, I did work for 3M for 7 years before I joined Monsanto. Worked in various locations across Canada, more dealing with my engineering degree, and then joined Monsanto in 1996. As I mentioned, I was in Muscatine, Iowa, and more on the Roundup plant facility manufacturing type work. Having that farming background and having that interest in agronomy, I was made aware of this program here at Iowa State. And I took that opportunity to go through the program, and I really believe that allowed me to move more to the seed side of our business at Monsanto. So showing that interest, showing that allowed me to go more to the seeds side, and now I'm located in Lethbridge, Alberta. So canola itself, it's a member of the brassica family. It's very similar to cabbage or cauliflower, if you're familiar with those. It is a genetic variation of rapeseed. The Canadian government and several universities in the 60s and 70s, they took it upon themselves to develop to turn that rapeseed into canola, basically low linoleic oil seed. They use traditional breeding methods to get it to that point. They really wanted to get that lower uric acid and glucinates, and a lot of that is canola is very similar to mustard. So if you were to taste a mustard seed, you'd get that kind of bite to it. You'd get that mustard sense to it. So that's what they had to breed out of that and turn that seed into something that could be used in the vegetable oil market. So here's some pictures on the side what the canola seed pods look like. They're about 3-4 inches long. They contain these little round 1 millimeter, 2 millimeter round seeds, and if you ever travel through Western Canada, in about that July time period, you'll see all these yellow fields, and there's a extremely high probability that that is indeed canola. The plants themselves, they're harvested for the actual seed. An average yield on a commodity would be about 40 to 50 to 60 bushels an acre, and basically the farmer would take that seed to a crush plant, and that plant would then turn those seed into oil. So a canola seed is very high in oil. It's about that 40 to 45%. Now some of the latest varieties coming out, they're around that 47, 48% oil. So they basically crush that for the oil, and then the meal that's left over, that meal's used for high protein livestock feed.
Can I ask you a question?
Sure.
How does canola differ from other types of rapeseed? What I think that it was in part just a branding of the particular selection by Canadian researchers. So you could comment on that.
Right. So a lot of it is for a plant breeder to say it is a canola seed, that this plant will produce canola, it has to meet, to get that variety registered, there's a long list of items that it has to meet. So uric acid, glucinates, how much protein it has, so there's a long list of things that the final seed produces that allows you to call it a canola. And that's important because that feeds into that whole crush plant infrastructure that leads into the, so they want to make sure they're getting the right type of oil so that it can be used for that, again, that vegetable oil market. So it has to meet guidelines to call it canola. So there is rapeseed out there. There is winter canola, and I'll talk a little bit about that. But there are other types of similar plants out there, definitely. Thanks. One of the big reasons canola was developed was to get a unique fatty acid profile. You can see, or maybe you can, the first line here is canola oil, and that's the saturated fat level. You can see some of the other plants and seed oils out there, how it compares to it. One example would be, so right now Frito-Lay has a contract for a specific type of canola that's grown, and they're using that. It's got a even lower saturated fat profile, and they use that for making their chips. So they've made a conscious effort that they're only going to contract canola. They're only going to contract a specific type of canola to make their chips for mass consumption, basically. Canola is primarily grown in that, like I mentioned, in that Western Canada area. There is some that goes down into North Dakota. This past year, there was around 20.3 million acres grown of the crop. There's about around the 50,000 farmers or so in Canada. It's a very important crop for them. it's about a half to a third of their revenue. So it's a very, very important crop for them. There is a little, as I mentioned, there's a little bit grown in North Dakota in this area. There is some winter canola grown in different areas in the U.S., but it's not really a major market down in the U.S. So a little bit about the canola industry itself. So canola is the second most consumed oil after soybean in the United States. So there is a lot of canola that's used within the U.S. A lot of other countries use canola. Europe, where it's also grown, it's primarily winter canola. So they will plant it in the fall, and then they will harvest it in that late spring time period. But that oil is more industrial oil, so they'll use it for lubricants in the food industry, where the actual food is manufactured. The U.S. is Canada's largest canola buyer. There's a lot of oil that goes down into the U.S., and about 50% of the edible oil is consumed in Japan is canola oil, and then a lot also goes into Mexico. Some of the specifics on canola production itself. It does like warm days, but not really hot days. So I understand it's been pretty warm in this area this summer, so it would not have been a great canola year here. Probably about a maximum of 32 or 35 degrees C would be it. What happens is during the flowering season, if the canola sees that high heat, basically those flowers will abort. If there's no flowers, there's no pods. No pods, there's no seeds. So it does like cooler evenings with lower humidity, and the lower humidity is more from a disease standpoint. Having the lower humidity does help control some of the diseases that canola is susceptible to. And it's about 100 or so day growing season. Canola is a indeterminate growing plant. So basically the canola plant itself will continue to flower throughout the season. It'll continue to flower until there's an environmental event that happens that will basically shut it down. So either it's going to run out of nutrients, or it'll see excessive heat. In a hybrid production, which I'll talk about, if there's nothing that will pollinate it, then it'll also shut down. As I mentioned, canola produces those yellow flowers. It's a real pretty crop. So if you're out there taking pictures, it's a really nice crop to take pictures of. That's for sure. And then in the fall, basically the plant dries down, and those long pods dry up, and the combine will come through, and basically you swath it, you put it into windrows, you let it sit for about 12 days to get that moisture down, and then you come by with a combine and harvest it. It's a very easy crop to a combine. From a commercial production standpoint, again, this is in the Western Canada. It's planted with very large machinery. So a lot of the big growers out there will have the 60, 80 foot air seeders out there that use canola, that they use to plant canola. The seeding rate's about 5 pounds an acre or so is what they'll use. So a 50-pound bag of canola does go a long way. 8 to 12 inch spacing in it, and the hybrid itself is a self-pollinating crop, so it does not need any pollinators to pollinate it. About 98% of the canola out there is either glyphosate or glufosinate ammonium resistant crops. So basically a lot of about 98% of it is GM crops. Now getting into a bit of the hybrid seed production, which I'm currently involved with. So this is what we do to produce those hybrid bags of seed for our customers. Canola hybrid seed does follow a typical seed multiplication steps. You start with plant breeders, which have thousands and thousands of lines. They come up with pre-foundation and foundation lines that narrows it down. You get your pre-launch varieties, get a chance to have those planted throughout your growing region, and then you come up with the 2 or 3 or 4 different new varieties that'll come out. So very similar to any seed multiplication steps that you'd have out there. One of the differences that I see from a canola standpoint, hybrid canola standpoint, and I'll just compare it to corn. Hybrid canola, the crop was developed, like I said, in the 60s and 70s. Hybrid canola was basically in that early 90s, mid 90s is when that came out. So it's a relatively new crop. There's a lot of changes. There's a lot of, yield advantages of, 2, 3, 4% are quite common from year to year to year. There's a lot of growth in that industry from a yield standpoint. When you compare it to corn, I think we're about as far as hybrid corn production, when was hybrid corn started? Is that in the 20s, 30s? Yeah, so we're about 1950 maybe in the canola industry from a hybrid seed development. So there's a lot of excitement in that hybrid canola seed production because it's so new. There's so many advances you can make on it. The hybrid seed production itself is pretty is a very intensive process. It's a lot. If you have any involvement or know how potatoes are grown, that's a big. It's very similar to that. Very intensive. We plant it in more in a 4-to-1 ratio is what we call it. But basically, there'll be 4 female plants in a row, and then there'll be 1 row male, then 4 female, 1 male. We do that because the male plants themselves, they have pollen on them, and the female plants do not. And we put bees into the actual field, either leafcutter or honeybees. So we put bees into the field, and the bees take the pollen from the male onto the female and basically restores that female so that the seed that female produces has all the genetics we want on that seed when we harvest it. And then we'll come along with a machine like this and remove those males once the flowering is complete. Because we want to make sure that our flowers and our male and our female, we want to make sure that they're flowering at the same time. We also do we take a lot of efforts. You can see here there's a picture of a machine that's trimming female to make sure that a lot of efforts made to make sure that things are flowering at the same time, so that if your female's open and is flowering and you don't have a male there with pollen, you want to remove any flowers on that female because it's kind of it is unknown where that pollen would come from on that female. Canola pollen flies about, we have to have at least a mile separation between other fields, so it's a lot different than corn if you're familiar with that. Their isolation distances are relatively small. Our isolation distances have to be about a mile. The final step in preparing the seed would be the seed cleaning process, and that's a typical small seed cleaning process that you'd see fairly similar to a soybeans, but more similar to alfalfa, stuff like, or small seeds like that. Oops. So now I'm going to get into the actual creative component itself, go through a little bit about the module itself. I'll get into what the module describes, get into how we identify spring canola diseases, disease impact on the crop, ways to reduce or mitigate the impact of diseases found in canola. When I was putting together this module, and one of the things I did to chose the 6 or so diseases that I wanted to talk about, I basically looked at across Western Canada, what are the primary diseases out there, what are the issues out there that our growers are having, what's the economic impact, and what's the on yield and quality that those diseases have. So that's basically the list I went through. And then the one at the end, the club root one, which I'll go into a little bit more detail. That's the disease that is relatively new disease, and I'll get into more explanation around that one. So all these diseases again, that I chose have some similarities. If you're familiar with, there are some similarities with soybeans and other plants, but seedling disease complex and root rot complex basically looked at, those are diseases that are very widespread, common in the root rot complex is more common in the northern areas. Blackleg is a big problem within canola. It's probably the most significant problem right now. It's very widespread throughout all the growing areas in Western Canada. There is also sclerotinia, white stem rot. That's another big disease out there for canola. Alternera, and then finally clubroot. When you look at disease, it is, and the amount of disease, it goes back to the disease triangle, basically based on, are there conditions that favor that host? Are there environmental conditions out there that favor that disease? And is that pathogen even there? Is it available? And how aggressive is that pathogen? So without those three things out there, it'll reduce the amount of disease. If you're unfortunate to have all those three things in abundance and in the right timing, as you know, then you end up with a big problem on your hands. For each disease in the modules, what I did was have a description of the disease, how to identify the disease, also the time period and growth when that cycle, when that disease can be identified. I also used a lot of pictures to make sure that people knew when they were going through the module, tried to be very visual on what the disease would look like and how to identify it. For each disease, I also looked at the life cycle itself. Without knowing the life cycle, it's hard to understand how to break that life cycle. It's hard to understand what you can do to reduce or mitigate that disease. So knowing that life cycle is a critical part of this whole module, making sure that that's understood and making sure that you know how that disease propagates year after year. And then one of the final things for each disease, making sure that there's a list of key management tools. So if you know you have the disease, you've identified it, you understand the life cycle, now you look at the actual management part to see how you can control or mitigate the spread of that disease. And again, using pictures throughout the module just to make sure it's clear on what it looks like for each disease. So the example I'm going to present is clubroot. And basically, clubroot is a canola disease. It's an obligate parasite, which means the fungus needs to have a living host to grow and multiply. The root on the left, that's a healthy canola plant root. So it's a nice long tap root with a lot of little roots coming off it. The plant on the right, that's a clubroot infected plant. And clubroot gets its name from, there's little galls that the fungus multiplies and forms on those roots, and it's basically an energy sink, and it basically causes that plant to mature real quick and not produce as much, so it basically hurts yield. Clubroot's a relatively new disease in Canada. It was found in 2003, and primarily in this is the province of Alberta, and right below it would be Idaho area is just right in this area, and Washington State's over here. So it was found in this south of the city of Edmonton. Basically, there's about 400 or so confirmed fields of this clubroot infestation in Alberta right now. Where I live and where the canola hybrid production primarily is in the south, in this green and yellow area, down in this area. The clubroot life cycle itself, so it does have resting spores that can live in the soil for about 20 years. It does have a half-life of about 4 years. But basically that resting spore will be in the soil waiting until exudates from roots of host plants cause it to be stimulated, and those spores go into zoospores, use basically water within the soil to get to those young seedling roots. When it gets to the roots of those young seedlings, it basically forms cysts on those roots, and that forms into galls. And again, that's the big energy sink for that canola plant itself, and can result in up to 50% yield loss depending on how severe that infestation is. But typically, it's around that 10 to 20% yield loss. Some of the soil conditions that favor clubroot infection, it does like warm soil, likes high soil moisture, and basically if there's areas in the field that are little dips in the field where a lot of where there'll be more moisture, that's generally where you'll find the clubroot infections themselves. You also find it at the entrance to fields. So if you have farm equipment going through and going around cultivating, digging up the soil, and if they're leaving the field at the field entrance, all that dirt will fall off maybe at the field entrance. So that's another spot that you'll find a lot of clubroot spores. It does like heavy black soil, so basically any soil that doesn't allow a lot of transfer of water, it'll like that. So some of the management things you can do to avoid or try to mitigate this disease. One is not to use the manure from infested land. If you're taking that manure, the spores are in the soil. You transfer that manure to another field. If you have cattle or straw bales coming through, if you use straw bales from that field, it could transfer the spores again from that field to another field. Right now, there's no registered fungicides for this for clubroot control that would be suitable for canola, mass canola field production. There's also, you could use calcium carbonate and wood ash to try and impact that the acidity of the soil, but it's not cost effective where canola is grown right now. There are clubroot resistant lines available now that are resistant to clubroot from several companies. So it was remarkable to see in 2003 when this came out, there was a lot of hysteria around clubroot that it was going to end the whole canola business, and then within 3-4 years there was clubroot resistant lines came out, and then now there's several really good lines out there that can control it. And also what the Alberta Ag, they also did a nice job of managing this disease, making sure that fields that had it were identified, and that those spores couldn't be transported to other fields. There's a moratorium put on fields where it's found. If you have canola clubroot found in your field, you can't grow canola on there for another 5 to 6 years, depending on how the infestation was. So there's a lot of effort put into making sure that this wasn't industry-wide disaster before some resistant lines could come out. And just a summary at the end here for clubroot. Crop rotation. Canola is typically grown 1 out of every 3 years in Western Canada on a field. A way to make sure you don't have you can reduce the impact of this disease would be making sure your rotation is good, making sure you've got a lot of years between as many years as you can between canola. Another thing you can do is when you leave a field, your cultivator or seeder, make sure that all the mud's knocked off, and It's probably good practice anyways for a lot of other soil-borne diseases, but to make sure that there's no that those spores aren't transmitted from the dirt that's on that cultivator to another field. And then just focus on agronomic practices to make sure that we've got good, healthy soil structure, so that to make sure that we can reduce erosion and spread of this disease will also help. So that's the end of the clubroot module. So for each of those diseases, it's very similar to that. You know, you go through how to identify it, what the causes are, what the life cycle is, how to mitigate the disease, and then a little summary at the end. After all that's done within that module for all those diseases, I have several summary slides at the end. And one of the summary slides I used was putting together a list of the disease on the left-hand side on this chart. I think the battery's gone in this, so I won't use that anymore. But on the left-hand side of the chart, there's the disease and then the stage of the canola plant itself, and the little X's denote when you could see that disease, to help understand when you should be scouting for that. Another tool I used was because it's so important from a disease standpoint to be able to visually identify a lot of these diseases, I used a little system here to list the actual disease and then a picture of a typical of what that disease would look like. And then you could match each in the module itself to make sure that you knew how it matched up, so you could identify that disease. So and at the end, it's I put together just a little summary around making sure that the agronomic practices are present, not only for canola, but you can use this for any crop that is grown out there. Scout early and often. Make sure you got the right crop rotations. Control your volunteers. Within canola, if there's a mustard plant, which is mustard is it is a weed within Western Canada, but it's very similar to canola. So the clubroot itself, it doesn't distinguish between the mustard plant or the canola plant. The mustard plant is a crucifer, so it'll also propagate, for example. So controlling those volunteers and controlling other plants like canola that are related to canola is really critical. Western Canada, direct seeding and reduced soil disturbance and soil runoff. That's just something that has really come along in the last 10 to 15 years. The majority of it is direct seeded. There's not a lot of rain. There's a lot of wind in areas, and making sure that you've got low disturbance is very critical to making sure you got good crops. Also, the use of fungicides. A lot of these diseases that I went through, you can use some fungicides on them, but the fungicides are only as good as the application, I feel. If you don't have good application, timely application, and done in the right way, it's difficult to get the control that you want. And that wraps it up. And just like to thank everybody here at Iowa State again. Helped me a lot along the way. If you get Alan's just absolutely wonderful as your creative component helper along if you do choose him. And there's a lot of great staff here at Iowa State. So one of the big things is talking to fellow students, figuring out what they're doing for the creative component. That also helps. So if you're trying to think what you're going to do, there's a lot of experience out there, past and present out there that can help you with it. And all the staff here at Iowa State, and finally my family for putting up with me while I'm taking another master's class. So. Good. Any questions?
Well, let's thank Dion for the presentation. Do you have any questions for him?
What is usually the rotation with canola?
In Western Canada, there's a lot of spring wheat, so hard red spring wheat, so planted in the spring and harvested in the fall. There's a lot of flax, field peas, barley. If you get into more feedlot areas, then they'll actually grow, depending on the heat units, but they'll grow corn for silage, they'll grow barley for silage and stuff like that. So that's a lot of the crops that are grown for rotation. Soybeans is starting to get into, if you look at the province of Manitoba, they're starting to get into that area, but there's just not enough heat units beyond southern Manitoba to get up and anywhere. So.
Where's the field guide located at then? Is it online or where was this placed when you finished it?
Oh,
Where does this exist?
okay. What will happen, okay, once Dion got done with his PowerPoint for his creative component, he also did not mention that for a module you have usually an 8 to 10 page introduction before that, and you can see those in the creative component sections that are posted online. But that information from that PowerPoint, his slides, his text, then is developed by Gretchen's group into a module, and we have a crop advisory institute that these modules are listed, and there's probably 70 to 75 different modules in there. We showed the orientation students that information this afternoon, and once we don't have his module posted yet because we go through and get approval by the American Society of Agronomy, so that module can be used for continuing education units.
So someone else to take our PowerPoint, or in this case,
Yes,
PowerPoint,
yes.
make a module
Yeah.
out of it. Okay.
Yeah. Other questions?
Did you locate a plant pathologist to work with?
Yeah, yes, yeah. For that club route, yes, yeah. So there's a plant pathologist we have one now in Edmonton, actually, that's employed by the company I work for. So yeah. A lot of it. So now if you think you find it in your field, there's a whole protocol on, taking the sample, putting in a big Ziploc bag, putting a couple wet paper towel in it, purulating it, FedExing it next day, making sure the location, the longitude, latitude where you found it, the GPS coordinates, and yeah, there's a lot of protocol on that to make sure that they can identify it.
Question up at the top there.
So you show honeybees in there, I'm assuming it's pollinated by honeybees. Are y'all seeing any concerns like there's a colony decline that they talk about there on the page here? Do y'all have any comments on that as far as are you seeing the same things up there?
So honeybees aren't allowed to cross the border between the U.S. and Canada. So that's one of the big reasons why that restriction's there. So now, having said that, there's not a lot of understanding, I think, around what impacts. So there's mites on honeybees. There's different diseases they get. I mean, it's a whole world out there. I'm not sure if anybody's, probably a lot of you out there are more familiar with it than I am, but that whole honeybee, managing that is quite the thing. So what my company does, what Monsanto does, is we only have 2 pollinators that we deal with. We select, what we think are the best pollinators from a honeybee standpoint. They have to show us, they're very restrictive on where they can overwinter, what other bees they can bring in, what other bees they can buy. They really make sure that the health of their bees is really strong, because if we don't have healthy bees out there, we're not going to get the pollination, right? We're not going to get that yield on that hybrid crop that we grow. We also use leaf cutter bees. So if you're familiar with the alfalfa industry, they use leaf cutter bees. So if you ever see yellow tents in alfalfa fields, that's what those leaf cutters do. They're meant to pollinate alfalfa fields. So they have a particular type of snout or nose on them that allows them to get into the alfalfa flower and actually pollinate it. We also use those type of leafcutter bees, and we use both type of bees because leafcutter bees like it really hot. They like really warm days, so they like kind of that 11 o'clock to 4 o'clock time period. Honeybees, if it's extremely hot out, they don't. They just like to kind of stay around the hive and keep that queen cool. So, so in our fields, we use both. We use honeybees and leafcutter bees just to make sure, that we can mitigate some of the environmental fluctuations that you see. So we get our quality and our yield that we want. Yep.
I have two different questions. One is, besides Canada and the U.S., are there other countries globally that are now major producers and competitors for canola production?
There's a lot of production in Australia. So I'd say that's, and they grow spring canola for the edible oil market. So Europe, on the other hand, there's more canola grown in Europe than in Western Canada, but that's for industrial use. So again, they take that oil and they'll use it to lubricate all the machines in a food factory, of some type. But there's a lot of programs in Australia right now. I would have to look. I'm not sure if they're on par or just slightly below the acres that we have. But there's a lot of canola oil grown in Australia.
And then can you comment on organic production with this crop? Is there very much of it? And presumably, if we talk about 98% of the acreage is now with transgenic, so those there would have to be canola varieties that organic producers use and give them.
Right. So there's the hybrid. So let me back up. So back in so the crop was developed in the 60s and 70s, and the seed production was basically done on open pollinated production, and that was done up until that early 90s, mid 90s, and then from there hybrid production kicked off, and that's the whole GM world. So in 95, let's just say there was about 5% was hybrid or GM, and the rest was that open pollinated. So now today, where we're sitting, we're at that 98%. Is basically hybrid production, and only that little 2%, that's that open pollinated. So there is some out there. I'm not really aware of where or how they do it, but there is some out there. Now, and where that demand goes, again, I'm not certain. Good question. I should find that out.
There's another question over somewhere, I thought.
When you say you need isolation distances of a mile, is that because of bee movements, or is there some open pollination that also occurs?
It's basically due to bee movements. So to get that hybrid field certified, we have a third party. All hybrid production, doesn't matter who you work for, there's a third party that comes in to certify that field, and that's the one thing that they will make sure. They'll make sure that there's that mile isolation around that field. If you don't have that mile isolation, the hybridity will definitely go down. Canola hybridity, to get it certified, has to be above 80%. So which is, you think about it, boy, 80%, boy, you got 20% to play with. But typical hybridities for canola, on an average year, that'll run around that 95% or so on a typical year. So it's not only honeybees that can pollinate, it's flies, it's any type of flying insect that's out there. If it touches that, something with pollen on it and goes to that female flower, it'll get that. And then also from a wind standpoint, the grains of canola are pretty small, so that's why that whole mile isolation has to happen. Which gets exciting from a planning out your year on who you can, on where you can plant this stuff.
Sorry about that, Dion.
Nope.
Question came up with regard to what the next step is. And this is what the module looks like that Gretchen's group has made. And so this is the title page. And if you have questions for Dion, I'll just step through. Maybe I will.
Had to press the enter button.
Huh?
I had to press the enter button to get it to go. Maybe not.
Yeah, of course it's stuff. While Gretchen's doing that, the other thing that goes with the module is that you have to develop some questions. And we usually have 20 to 30 questions that are developed for the module. And here's an example of one of the questions, and they are questions that are 4 answers, and then the person can go through and step through and just select what the answer is, and then you can go to the next question. So that gives you some idea of what that looks like. To go back to what the module looks like, so you will have a module that looks like this. This is going to save me time tomorrow.
Great. Yeah. No, this is good.
Maybe I can sleep in tomorrow instead of coming in. But so you have your introduction initially, and you can step through. You see down here you have introduction, and you step through the various slides. You have a combination of text and graphs or pictures. Again, everyone learns a little different way. Some learn by text. Some people like to have that picture there. So you can go through that, and you can see that these are some of the slides that he pulled through. And so you have your diseases listed, and you can jump to those particular disease and just go through the 1 to 5 sections that are on that particular disease, showing the life cycle, the management, some pictures of the disease, and ending up with a summary. So that's what Gretchen's group does after the student submits a PowerPoint to them. But they put in the text, they put in the pictures that you want, and then we can have interactions in there. Yeah, let's see if I can get to that interaction. That's the summary, isn't it? Maybe it's right there. So this is the club group section that he went through. Actual slides. Summary. Here's a picture showing the diseases and the growth up at the top. And on some of the items you can click on and get picture expanded. And then on the next one, right here. Here's the place where you select and drag down the text, the interaction, and that wasn't correct. So if you know which one you're looking at, you can drag down and fill in the blanks there, basically. So the interactions that are going into these modules, just kind of expand and think about what you can do, because if you can think about it, Gretchen's group can usually build it for us. And so I wanted to just kind of show you what that looks like.
Can you show them a list of all the modules that are available?
Gretchen's going to have to do that. You have to go back to the main site.
Do you want to talk about pictures and referencing pictures?
Yeah, we'll talk about that tomorrow. Referencing.
Because that's an important thing. Because if you get the picture and forget about it.
So there's the list of modules, and they're grouped by crop management, nutrient management. Well, she's going so fast. Soil and water. We have a lot of pest management, but if you're interested in developing a module, something on nutrient management, or what's the next one down?
Professional development.
No,
Oh.
at the bottom, yeah. Soil and water management. Those are 2 areas that are very limited on modules and for getting people, CCAs, getting that continuing education units. So those are a couple areas big interest.
How many of you are CTAs?
There's quite a few.
Okay, so you know all about continuing education, and this is one way to get continuing education units or credits. You should also know that you get credit for being in the program, and that we can help you earn. If you're taking classes in the program, you won't need to do any other continuing.
Any other questions for Dion about his presentation or how he got the topic or what he did there?
I'll go back to that slide. That one's good.
Yeah, go back one, and that shows the one with the credits, yeah. So this shows the credits that you can get for taking a particular class. So for 501, you can get 45 credits.
2 years.
And that's you are required to have 40 credits every 2 years. So if you take a couple courses, you can pick up your major portion of your continuing education units for that certified crop advisor.
So question on that, is it just a semester in which you're taking it, or how does that work? If you've taken those and haven't had them applied to it as of yet.
I think we can get them for you. I like that.
John?
Yeah.
He's the expert.
I am in direct contact with the certification office in Madison, Wisconsin. So whether it be a crop advisor in the CAI module exam that you've completed, I will get emails of whether you've completed them or not, and I send the test results to the certification office. And did you explain how the modules get certified and all
Well,
that?
they're more interested in getting credit for
Right.
classes.
So when you take classes, whether are you those of you that are CCAs, you have a certain cycle. Is that correct? I'm not exactly sure. So as long as you report the class with it before your certification cycle is up, it can be the semester after you take it. You just need to let me know because I'm not tracking CCA. And I don't track CCA students who are also need those credits. So when you're done with the class, just give me an email saying, can I get 501 credit? Can I get CCA credit for taking 501? And I'll contact the office, and we handle it that way. So it's as simple as the email.
There you go. It can happen. You just need to send her an email and she'll take care of it for you.
Yeah, and they're not terribly picky about when you actually took it, as long as you report it before your cycle is over. If that makes sense to you, it makes sense to me.
Other questions for Dawn or Gretchen?
And they require a C or better grade as far C or better grade. And grad college requires B or better, so there's usually not an issue with that.
Other questions?
You have a chance now
Yeah.
to question a graduate of the program. So ask him questions about his experience and his advice.
Look at this like. Yeah,
Or we can get Lucas down here too.
Where do you get most of your information?
So a lot of it was done from, so a lot of sources would be online. There's canola itself. There is a canola council within Western Canada. They have a lot of good, either references or information on that site itself. I happen to be surrounded by, at work, what I consider, 4 or 5 of the really, really solid agronomists from a canola standpoint. I'm sure they were sick of me, asking questions about this module as I went along. So it's kind of pulling from wherever I can. And one of the reasons why I chose this topic was because I felt like I had all the resources at work already. I had good contacts, that this wasn't something I had to do, that was so much far removed from my day-to-day responsibilities that it kind of fit into my everyday life, so to speak. and help me with my work.
Any other questions?
How long
Oh.
from start to finish?
From start till finish. So would start be when 6 months of Alan saying, when are you going to start? When are you going to start?
You mean the whole program or just
No, just the creative.
Oh.
So that whole, I want to say 4 months probably. 4 months, 5 months?
A good 4 months of
Yeah, back and forth.
developing the material and
Yeah.
going back and forth with it. And again, I think I mentioned it yesterday that, or maybe it was Tuesday. If you're going to graduate in the spring, it's good to have a rough draft of everything beginning of spring semester. You don't try and do a module, say that in spring, January, I'm going to do a module. You're not going to get it done in time.
So, I mean, personally, I treated it like a class. I mean, I threw it on my Outlook calendar, and I said, you know, tonight from 7 till 9, you know, Tuesdays and Thursdays I've got class, and I worked on this, or on the weekend, whatever. Just because I had to carve it out, because I think I went 3 or 4 months saying, yeah, I'll do it, and I never got to it. So I had to treat it like a class in my mind to get on it.
And we have a template, a PowerPoint template that you can use that basically has your chapters, your introduction, and you put in the chapter names that you want to call it, and you just drop it in. It has information with regard to the size of the text, because we have a kind of a standard size text that we use, and then places that you put pictures or tables or graphs or anything of that sort. There was a question over here.
Were you able to see a lot of these diseases in the field, or is it something that, you know, it's still kind of abstract?
Yeah, definitely. You know, being in the hybrid seed production business, yes. You know, definitely a lot of these. The only one would be the clubroot one. They have a yearly kind of midsummer trip that you go up to around Edmonton, where all that clubroot is happening. That's the one we actually have to go and, you know, make a trip to go see it. But otherwise, throughout the year, you'd see you know, occasions of any of those diseases. So, which is also really nice, because you go, hey, what's this? And then I was telling you, those 5 or so good agronomists that work for me, they were able to say, yeah, that's a blackleg, or that's sclerotia. So.
Question up at the top there.
Sorry, the template you're talking about, is that only for the CAI module, or is that what we could use if we're doing a research project and putting together? I'm assuming it's going to be a PowerPoint presentation too when you come to present it. Is that correct?
Well, yeah, it's going to, when you present it, it's going to be a PowerPoint presentation, and we do not have I mean, it's just a standard PowerPoint presentation that you put together, and you can use your background. We don't have a standard one for that standpoint. We have, we've had some students that they wanted to put some people put on, like Iowa State University that you'll see. We had one student that wanted to put on Nebraska, University of Nebraska, and I kind of discouraged that. So,
And you want to pass? Don't do that.
but this is for the template in building, and we also have a template that you can get from Dawn with regard to just the standard format of a title page, introduction, materials and methods for doing a research type creative component also. Other questions? I think that's it, Ken.
All right, thank you. So,